Hello. Now we are going to talk about the list comprehension. Now, since we have started this course, right, we have been looking at this list comprehension for a longer time, right? So again, like understanding about the list comprehension should be easy, right? Now, here, consider an example. So consider that, like, let's say that if you have to append the square of all the 100 number into a list, right? So this would be the one approach that you might follow without list comprehension. So first we'll build a empty square. So here we have this empty list. We are taking the loop from 1 to 100, and then every value is being squared and then appended to a squares, right? So every value we are trying to make a square of each value, right? And then we are appending to this squares list. So this would be the good approach for the traditional techniques, right? So let's run this. Now we can take a look at this first 10 object. So here we have this first 10 value of squares, right? 1, 4, 9, 16, so on. Now you can do the same approach using the list comprehension, and this is much more easier. Consider this. So what we have to do is, first what we have done is, first we have created the empty list. Now, so again we can rewrite this, right? So first we have created the empty list. Now we have started writing the for loop. We'll do this for I in range. We can pass the same code 101, right? Now what we want to do after that, we want to append these I of square. So whatever the value you have to append, you have to write it over here. So here we're saying that I of square, and that's it. This is what we have to do. Let's run this. We can check the value. This is what the list comprehension is, right? Now consider that. Let's say that if you want to only store the value which is the like, so here you want to build a list of squares for even positive integer only. So we want to only store all the positive, this even number value, right? So we have to filter all the value which is even number, and then we'll have to take the square of that. This is the most traditional way you want to try. Here we have this list, we are taking the loop. Now we are trying to check whether this each value is the even or not, right? This is the code which will help you to filter out the even number, and then if the value is even number, we'll take the square of that and then we'll append that value to the list, right? So let's do this. We can take the first 10 value. Now we have all the value, all the even number value. Now you can do the same thing with the list comprehension in this way. Again, the same approach. We are saying for I in range, first we'll create a list. Then in the list, we'll write this loop for I in range. And then after that, we have written the condition. So we'll write the condition over here without colon. Here we are writing the condition. If I mod 2 equal to 0, then whatever the value we want to append I of square. So that code will be written over here, right? So here let's do this. We can check the value. So we have this matching value, right? Now, although we have been writing the list comprehension on a single line, so we can also write or use a multi-line code over here. So in the list also, right, here we can check that, right? Here we have this for I in range. If this conditions, then again we are storing the value. You can also use this multi-line approach to build a list comprehension, right? Now we are going to talk about the nested comprehensions. So let's see a first simple example. Suppose we want to generate a multiplication table. How would you do that? So the traditional approach is, first we'll create a list. Inside that list, so again we have this list, then again we have this written the loop of 1 to 10. Now again we are creating another list which is a row. So this is the outer loop, this is the inner loop, right? We are saying for j in range, and then we are appending I into j over here, right? And then whatever the value, so first we are appending the value to the row. So row will hold the multiplication of, first let's say that if I is 1, Then we'll multiply 1 into 1, 1 into 2, 1 into 3, and 1 into 4 till 1 into 10, right? And then we'll store that value to that row. And after we finish the row, we'll store that row to the table. Then again, if I is 2, same code. Then again, if I is 3, same code, right? So here we have written this multiplication table between 1 to 10, right? So this would be the one approach. Here we can see that this is the table we have, right? So this is the table of 1 to 10, right? Now we can easily achieve the same thing using list comprehension. What we have written is, first we have this list. So what we are storing over here in the outer list, in this outer list, we are storing this row, which is this row, right? So in the outer list, we are storing a list value only. So here again, as we know that whatever the value you want to store, you have to put it at front. So we are writing this loop. So again, this is also a list comprehension. So here we can see that we have the list comprehension value in the list comprehension, right? Again, we are saying for j. So first we are solving this for j in range, right? And then we are adding that row. So we're saying for j in range, right? And now we are multiplying I into j. Again, remember here I has not initialized still, but now first we'll say for I in range 1 to 11, this I value, which is a global for this list, right, will be put over here, right? So first this code will execute, and after that this code will execute, right? And then we are storing the list of list over here. Here we can see that we are getting the same value over here, right? Now we can also achieve something else. So here let's construct a Pascal triangle, which is just the triangle of binomial coefficient. So here is the Pascal triangle is, and here is the calculation that we can use to achieve these Pascal triangles, right? Here we have is n, and then we have the k, and then we have to calculate the Pascal combination for that, right? Now what we have to achieve is, so here we have this. So see, like here, if the again like this, so we have this row and the column. So first is row, then again, so one row, one column. In the second line we have the two row, two column. In the third line we have the three row, three column. Third row and three column. Fourth row and four column, right? So we have to take row and the column both, right? So if row is 0 and the column is 0, so we'll get 1. This is what we are getting. And if row is 4 and the column is 2, where is row 4? 1 2 3 4. So 0 1 2 3 4. This is this row we are talking about, and the column 2 is 0 1 2. We should get 6. Here we are getting 6 over here, right? In other words, we have to calculate this. We need to calculate the list of list, right? So here we are using a factorial to calculate the factorials, right? So this function will be using to calculate. So n will take the row and the k will take the columns, right? Now this function we are using, first we are saying this for n in range, right? And the size we are saying as 10, so 10 plus 1. So we want to create a Pascal triangle for 10 value, right? So for n in range 11. Now, so this n will be considered as a row, and now this list will calculate the actual value by considering column and row both. Here we are using these combo functions, and now we are storing this entire list in the outer list over here. If we'll run this, we can say this is the output we are getting, right? We can also do the nested loop, right? So again, nested loop is not nested comprehension. So nested loop is here. So sorry. So this is the nested comprehension. Like we have this first loop, and then this first loop inside the outer this outer list, and then we have this an inner list, which is again we are in the inner list. We are again doing the list comprehension. So it's a list comprehension inside a list comprehension. That is called the nested comprehension. But now we are talking about the nested loop. Consider this. Suppose we have the list of character. We have this L1 and L2, and we want to produce a new list containing the pairwise concatenation character. That means we want to achieve A into X, A into Y, A into Z, right? And again we want to achieve b into x, b into y, and b into z, and so on, right? So how we can do that? So this would be the traditional approach. First, we'll initialize these two lists. We'll store the result in a so here we are storing the output in this result list. Now first we are taking the first loop, then we are taking the second loop, and then we are multiplying these value, right? So S1 and S2, and then we are storing that value into a result. Consider that here we are not using tool list over here, right? So like this, we have used a tool list. So this would be the nested comprehension list inside a list, but this is not a tool list problem, right? So this is like multiple two for loop we are using to iterate all the value. And then we are multiplying both, or sorry, we are concatenating both string, and then we are adding the result. And this is the traditional approach we can follow. Here we are getting the result, but we can achieve the same thing using the comprehension technique. Like so, here we're saying for S1 in L1, then again we are writing a for loop for S2 in L2, and then we are saying S1 plus L2. That's it, right? It's a more cleaner approach. Right? Now we could also expand this by specifying that pair result in the same letter twice should be omitted. Right? Again, I'm saying pair result in the same letter twice should be omitted. This is what we are trying to achieve. So here we're saying that if both value, like over here, we have the two list L1 and L2. Here A, B, C is the value, and then we have this B, C, D. Now this B and C is common in this both list, right? So we do not want a common calculations. So here we can filter out that. Let's say that here we have this two loop, and then we are saying that if S1 is not equal to S2, then only we want to append, otherwise not, right? So let's do this. As a result, we are getting this ABC. So here we are not, like here you cannot see this B into B and the C into C, right? So the common has been filtered out. Based on these conditions, you can achieve the same thing. Here we have this two loop, then again the condition, and then we are adding the value over here, right? Now let's see how we can let's see how we can use the zip function, right? So what the zip function does, let's say that we have the two iterable object. If you zip these value, right, and then if you like convert this generator to a list, right, so you will get these value, right? So here we are getting this pairwise value, 1 into A is like 1 and A, 2 and B, 3 and C, 4 and D. Again, now from the 5, 6, 7, 8, 9, this list is not matching, so it will only calculate for the lowest length of list, right? So we'll only get these result over here. Now we can do the same thing using traditional nested loop. Here what we can do is, here we're saying that, so this is the cleaner approach for the zip, right? So we have this empty list. Now we are trying to check with the, again we are using the enumerate function to get the index and the value both, right, for the both loop. Again we are saying that if the index is matching, that means what we're trying to do, we are trying to add index of 1 and 1 and A, index of 2 and B, index of 3 and C, and so on. So we are matching the index, and then we are appending the tuple of, so again then we are appending the tuple to a list. We can achieve this result over here. You can also achieve this using traditional using the list comprehension. Again the same code will be written, but again all the code will be written in the list, right? So this is the multiple approach to use a list comprehension, but the zip is the most cleaner way that you can achieve, right? Now list comprehension can also be quite handy when used in the conjunction with a function such as sum function, right? Now consider that suppose we have the two-dimensional vector. So suppose we have two n-dimensional vector, not two-dimensional, we have this vector 1 and vector 2, both have n-dimensional vector representing as a tuple, and we want to find the dot product between two vector. What you have to do is, in result you have to multiply C1 and D1, then plus C2 and D2, plus C3 and D3, and so on, right? This is the result so this result would be the result for the dot product. So how do you do in a traditional approach? Let's say that we have these two vector v1 and v2. Now what we are doing is we are taking the loop, of length of the vector, right? And then we are extracting each index. So again, then we are extracting the value of each list via index, multiplying both, and then we are adding to this dot number, right? And then we'll get the dot product of two vector. You can do this using zip and the list comprehension as well. Using zip, you can do that way. So first we are taking the loop. So we are zipping these two vector. Then we are extracting both value over here, right? Here we are extracting both value I and the j from each element, and then we are multiplying those value, right? And then we are adding to a list, and then we are passing that entire list to sum. So we are combining zip and the list comprehension both over here, right? So actually in the sum, if you are using a sum function, you do not need to use the list over here. You can directly write this list comprehension technique in the sum function. This will work, right? Now, now what we want to know is, so now let's talk about some global scope. So there are some problems. Whatever we are doing in the list comprehension, we have some problem, and we have to account for that, right? So we have to be careful for few things over here. Now first, make sure that we do not have the number symbol in the global scope. So first we want to delete the number symbol or the number variable from the global scope. Again, you will understand why we are doing so. So first we are trying to check that if the number is then we want to delete it. Now let's say that if we are trying this approach, we have this number for number in range 5, right? So this is the loop we are taking, and then we are taking the square of each number, and then again we know the result. So here, what was the scope of the number? So we want to check whether this number has been created as a global scope or a local scope. Let's check it. This will give me, if the number is in global scope, this will give me true, otherwise false. It is false. So this number is created as a local variable inside a list comprehension, that it is not in a global scope. But what if the number was in our global scope? Let's see that. Here the number was 100, right? We are creating a number as a global scope. So this is the variable, and the value is 100 we are using. Now again, let's do the same technique here, and now let's take the value of number. What is happening? Because the number was in the global scope, right? So this number has, like, this local scope number is not affecting the global scope number, right? So as we can see, that number in the list comprehension, it's still a local to the comprehension, right? Our global number, our global variable has not affected, right? Now because number in the loop, so number is the loop item, right? So we are taking this number in a loop, right? So this number gets assigned a value before being referenced, right? So here we can see that, consider this, we have this number as 100, and now we are saying that for I in range 5, we are trying to multiply this number with I, right? What value we will get? We'll get 0, 100, 200, 300, and 400. As we can see that the scope of comprehension was able to reach the global variable. We are able to capture the global variables, right? Same as functions. Now let's look at it. Now let's look at an example, right? So here, consider this. Suppose we want to generate a list of function. Okay, here we want to generate a list of function that will calculate the power of their argument. That is, we want to define a bunch of function over here. So what we can do is, here we are defining a multiple functions. We are defining function 4, 0, 1, 2, 3, 4, right? And each function is multiplied by the, so function 0 is giving you, like, returning you the power 0. Function 1 is returning you the power 1. Function 2 is returning you the power 2, and so on, right? Let's create this. But this would be very much tedious, right? So now we can also achieve the same thing using the loop. So here we are trying to use the list comprehension over here. So first you can do this Similarly, like we are using this lambda x, x square, lambda x, x of 1, and so on, right? We can do this manually. Here we are trying to do the same approach like this function. We have this, but we have this list of function, right? We are not using a loop, but again, we'll soon. We have created this manually, right? And now what we want is, now we are trying to call each functions. We are trying to call each function by passing x value as 10. And what we are getting the result? We are getting the result as expected, right? Now, all we need to do is to create this function using loop. Let's say that if you want to create this function using loop, the traditional approach, right? First, let's try to remove the global let's try to remove this I variable to the global scope because we are going to use that, right? Let's do this. Now what we're trying to do is, again, we are trying to use a loop to create these functions. We are taking the loop for I in range 6, which will be value between 0 to 5. And then we are saying lambda x and x to the power I. And then we are appending these lambda functions to the function list, right? This looks great, right? Now let's do this, and now let's them. So now let's use them, right? So here, what value we are getting over here? So we are not getting the expected result, right? So we are getting 10 to the power 5 because at the last time when this loop broke, the value of I was 5, and this I value was not earlier from the global scope, right? We can check the value of I as well. So this I will become a global variable over here. If we'll check the value of I, it will be 5 now, right? So this function has been created, but the I function has been used for the last for loop value, right? Here we are not calculating it. If we would have done the calculations, right, then there would have not problem. But here we are not calculating it, but we are using that I reference value. Remember, in every loop, the value of I reference changes. In the last loop, the value of I was 5. So lambda function has created and the I becomes 5 over here, right? Because the value of I is 5 now. So here what happened is, so in the first iteration, the value of I was this. So we have created a function, right? Now in the next iteration, the value of I was 1. So we have returned the same function, but this time the value of I become 1. So this function I and this function I has 1 now, right? So because I is global variable and we are changing the global variable value. Now let's set the value of I is 5. Here we have created two functions, fn0 and fn1. Every time the value of when we created this function, the value of I was 0. When we created this function, the value of I was 1, right? Now here we are setting the value of I, which is a global variable, as 5. Now let's try to call the fn0. What will happen? When we call the fn0, it will consider the value of I was 5 because we have given the reference of I variable and the value of I variable is 5 now, right? So this is what happening inside the lambda function. Again, if we change the value of I again, let's say the 10, now it will run this 10 to the power 10. So this is exactly what happening to our loop, right? Every time when we so we here in every loop we have created a lambda function as x colon x to the power I. Same function has been created, right? But because this loop has been created like rolled for 5 times, so we have created a 5 function and every function is same. And then it is using the reference of I variable. And then the last time the value of I variable was 5. And that's the reason it has, so every function is behaving and giving you the same output, right? Again, we can see that here when we run this, we can see the value of we can print the value of I is 5. Now let's delete the I value now, right? Again, a same thing will happen if you use the list comprehension. For that, to use this, to see this, let's delete the value of I. We are checking the I in global. No, it's not. Then again, we are writing the same function in the list comprehension. right? When we are writing the same function in the list comprehension, right? So we have created the list of function. Now let's check the value. This I has been created as a global scope or not. It is not. I is still local. So I has not created a global variables. It is a local variable. So, but again, it will behave the same way that has behaved over here, right? Why? Because even though I is a local variable, right? I value is, so every time we are adding this function by taking the reference of I, and by the time when this for loop ended, the value of I was 5. So this function will also, this list of function will also behave the same way that it has behaved earlier. We can check that. Here we are trying to check that function 0 and the function 1 by passing 10, right? Both will give me same output, right? Now, so the problem is how we can fix this. We can fix this by assigning a variable, right? We can fix this by making each current I value as a parameter default for each lambda. So here what we're doing is we are saying again, now the function we have changed. First, this loop is there for I in range 6. And now we're saying the lambda x. Now this time this lambda function takes two argument, x and a power, but this power function is being defaulted. So every time when this for loop will go, the I value will change. First time the I value was 1. Now and then it has added this lambda function, and this time the lambda function, so and this time the lambda function becomes lambda x and the power equal to 1, because here we are using this power as a default parameter, right? And the value is being fixed because of I. So now we are not using the reference of I, right? Now we are using a default parameter, and here in the value we just have to do x to the power, like x to the power, like x raised to power, or whatever the value of power is, right? So now here we are not using the I reference. Whatever the value of I is, we are setting that value as a default parameter in the lambda function, and now we are using that default value, right? And this is different than the earlier code, right? Now let's try to run this. Now this will be a fixed problems, right? This is how we can fix the problems. So if you have any parameter which is changing and then you are using to create any function, you can use that function to create a default parameter, right? You can use that variable and create a default parameter, and then you can use that default value into the function, right? And yeah, this is it about the list comprehensions, right? Thank you very much.